I will call on you during notes, and they'll know that your number is up. Student number 25. Here you go. Then you can tell mom, dad, parent, or guardian that was me. All right. And then that means x equals -2 and x equals 1/3. I was just going over the zero product property, and then you could stop the video if you wanted to take these little three sections because that's what we're doing today. We're solving quadratics. Yesterday you factored factoring methods, and then factoring is, if it can be done, a good way to do it and fast and efficient if you're good with factoring. You don't want to use quadratic formula every single time. You're going to run out of time on a test. Some people do that. It's not good. Square root method depends on what's how it's given to you. Let me go back to the factoring zero product property. Sure, -2 is a solution. I hope you can get that. Subtract 2 from both sides. When I plug in -2, I get -2 plus 2, which is 0. -2 times 3 is -6 minus 1 is -7. But 0 times -7 is 0. True. I've been telling you since day one, looking at an equation, what does it mean to have a solution? It means when you plug the number in, the equation ends up being a true statement when you're done. All right. Same thing with 1/3. 1/3 of 3 is 1. 1 minus 1 is 0. Who cares? 2 and a third times 0 is still 0. True. That's what it means to solve anything. That's why an inequality needs an infinite amount of answers with a number line check, because there's more than just one or two answers. It's a whole set of answers in between. Square root method. That's when you have a polynomial in a square set of parentheses. Whatever you do to one side, say it. Okay, so what do I do to both sides to solve for this? How do you get rid of squared? I'm about to write it. Everyone say it in 3, 2, 1, go. You square root both sides. But the problem is people forget about plus minus possibilities. And I'm actually going to cover that right now. I'm going to put it right here. Just tell me we'll start with the 25, student number 25. Tell me what two answers make that equation true that I wrote over here. So what squared? 2. And then what else? Or -2. This is the why. When you square root both sides, you have to put a plus minus because it's true, because it happens. Yeah, I don't want to choke myself in the cord. All right. I'm cheating. I'm bringing the seating chart over here, even though I shouldn't say your first name online. Sue me. All right. 2 squared and -2 squared. That actually equals 4. So this is the why. It's the only reason why you put plus minus when you square root to solve. I mean, I don't know what else to say about it. You got to do it. And I say this now, and I hope you're different than CAT students of the past. I won't say anything after this. This is the number one error I see people do. They don't put plus minus and get two answers and move on from there. Okay, so with that being said, the quadratic formula should only be used as a last resort. All right, and it should be used when it's not factorable. Should never use the quadratic formula when you have something in square, like the square root method form. It's a waste of time. You triple the amount of work that you need to do. All right. So from here on out, this probably happened to you last year where you would say not a real answer. But we talked about I numbers. So if you're solving a quadratic equation, you don't have to write all this down. But over the complex number system, some of the answers will be imaginary and you will have to show that. The complex number system is actually the system that is made up of both the real number system, that's like a set of numbers, and the imaginary. I made a mistake when I was young as a teacher. I thought complex meant I. Oh, complex means it's an I number, folks. It's wrong. The complex number system is the overall system that incorporates both real and imaginary. All right. And then in the real system, that's where the whole numbers, you guys recognize these terms? Integers. You ever hear that term? Someone shake their head, please. This is college algebra trig. You should know what an integer is. An integer is a not fraction, positive and negative. Whole numbers, 0 positive numbers, no fractions. Counting numbers, those are called natural numbers. Don't worry about these. Then rational. and irrational numbers. Those are all in the real set of numbers, right? Just so you know. Okay. Did that really count for student number 25? I guess we'll allow it. Who's next? Oh, this is the angry student. Nice. All right, here we go. Okay, so what do you think we should do with this first? And this will be just says solve quadratic. What do you think I should do with this first? How's that gum, by the way? Good? Good. Yes. Okay, so when you have a quadratic, you do not want to like try to like in your like we solved like second day in here. You don't want to try to isolate the variable. You have an x squared and an x. They're not like terms. So what you need to do is maybe get them on the same side equal to 0 and either factor or quadratic formula. This is not square rooting form. This doesn't have like a nice set of binomial squared. So the next thing is probably going to be factoring. How does this factor? Or what do you get when you factor this? Nice. So then what does that mean the factors are? Mm-hmm. Good. And then good FOILers, good factors. I got it. X squared, negative 3x, negative 5x, negative 8x. I'm good. Negative 5, negative 3, 15. Here's where this gets to be a problem. When we, instead of just say factor, and then you write the factored form, and solve, people do the MA and then write that those are the answers. It's not the case. When you do the zero product property, please don't write this in the future. I don't expect you to. This is a high level math class. I think we could skip that step. Imagine that x minus 5 equals 0 and get x equals 5 and also x equals 3. Okay, so I don't want to see that second to last step necessarily. But for no purposes, the difference between MA to get the factors, then the zero product property gives me the answers. And then when I plug in 5, 5 squared, 8 times 5 is 40. 25 minus 40 does equal negative 15. True. All right, and that's why 5 is the answer and 3 the same thing. Not going to bore you. Probably too late. But anyway, who's next? 4. See, this is why I'm going to cheat on the thing. All right, Nicholas. I don't know all your guys' names, but I could just say the first name. Could be anybody. All right. So I just demonstrated the zero product. This times this equals 0. So I did a zero product property. I do this every year with the same example. Is there a 20 product property, Nick? Yes or no? You would think you wouldn't think so, correct? Is that what you said? Yes. I don't think so. Good. Heck no. First of all, you'd say x equals 20. So I plug in 20. 20 times 3 times 20 plus 11. Does that equal 20? Yes or no? No. So I do that every year. Some people get goofy like that and they make up a rule. I'll tell you what you have to do, Nicholas, and you got ended up with a tougher one that I'm going to make you do a specific way. This is going to be in the future a quadratic. So you have to do exactly what the last student just did. You must get everything multiplied out, get the x squareds and the x's and the constant, get it equal to 0, and then factor. Okay, now I'm going to make you do it. I know this is a little bit more challenging. I'm not going to let you do a 4-stepper. Nicholas, you have to tell me what times what equals 3x squared, meaning that's what we're going to put in first. So I'm starting to factor this, and I'm doing it the unfoiled direct method. So this times this equals 3x squared. What are the only possibilities there? So what times what equals 3x squared? I'll give you a hint. One of them has an x on it, and one of them has an x on it. So x times x is x squared. So one of them has to have a what in front of it, and the other one has to have what? 3 and 1. Okay, so that's the beginning of unfoiling. I'm making you do this. So I'm making you, because eventually we do have to be this way. All right, and then I'll go through a couple numbers. This last, so this takes care of this. Maybe I'll highlight this. this is how we reverse engineer, factoring a polynomial, reversing a FOIL. Well, the next thing is what times what equals negative 20. I'll help you on this. 20 and 1. I mean, come on, 21, 3 times 20 is 60. We're looking for the middle term, not that. 2 and 10, 2 times 3 over here would be 6, and then 10 here would be 10. That's a little too big, too. I think we're looking at 4 and 5. You tell me where the 4 goes, where the 5 goes. See if you can figure it out. And again, don't feel bad if you put it in the wrong spot, but feel bad when you don't check. So tell me what should go with 3x, the 4 or the 5? Okay, we'll put the 4 here. And then what? You said plus 4. Good, you're giving me the signs. And then that one has to be what? Negative what? 5. And then wait, are we sure? I think we just have to make one slight adjustment. When I take 3x times negative 5, that's negative 15x, but positive 4x. What's the one thing we have to change? So I would get a negative 11x. Yeah, switch the signs. And this is what I really want you to do. I want you to, fill it in, check it, and then make an adjustment. Ultimately, it will be faster. Ultimately, it will. Okay? For sure. So that was a tough one to ask someone to do that, even if they may have committed to, I'm just going to do the 4-step method and not do what Mr. Samuelis makes me do. All right. Then I hope we can get good with this. To set this equal to 0, you would add 4, then you would divide by 3. I hope everyone could get 4/3 out of that. And then this one, you'd subtract 5. So these are the two answers that solve that equation. I'm not going to plug them in and bore you. Okay? So I set this equal to 0. I added 4, and I divided by 3. That wasn't too fast, was it? The x plus 5 would equal, x equals negative 5. No, because this is, I'll write it. This would be 3x minus 4 equals 0. The very first thing I'd have to do is add 4 to both sides. And then divide by 3. So try to visualize that. We are in CAD. I do like these shortcuts, in order to get those things. All right, next. Oh, boy. Yeah. Oh, nope. You're not doing 4 steps on this one. No way, student number 14. Where are we at? 8, 9, 12. Is that you? Wait, where is your lucky number 13? No. You're 13? Okay, here we go. No way you are not doing a 4-step method. What times what equals 2x squared? So what goes in those 2 spots? You get, I don't care where. Bless you. Bless you. To the nurse. You're quarantined. Oh, that's over. What is it? I don't know. Who knows? 2x? And what? Okay, so 2x times 1x is 2x squared. This is why this should not be a problem. What times what equals negative 3? Like, what are my only options? There's only 2. 1 and negative 3 or negative 1 and 3. So you really have only 4 different things that could happen. I want you to try to pick the right one, like right off the bat. Now what you're doing is you're thinking about this and this, to get that middle term. You're looking at those. So you have 3 and 1 that's got to go in one or the other. Nice. And I like the way you say that. Let's double check it. First of all, everyone should know 3 goes here because 2 times 3 is 6. We need to get 6 minus 1, 5, and we know we're going to have a positive and negative. But here's the thing. If you don't know your multiplication rules, knowing that the last has to be a positive and negative, those are the problems that we run into with this factoring. All right. All right. I got to speed this up there. So hopefully, maybe I'll write this again. I would really hope you don't have to write this step next. Really hope that you can wean yourself from that. Add 1, divide by 2. subtract 3. I hope we can do that and get to that at least. Right? Know the difference between getting the MA numbers to factor, but then that's different. Well, actually, I'm thinking about the first one more so. Right. This is why I'd be infinitely sad if you did a particular thing for this. Like, okay, I already showed you that's the second thing that you should look for. If you foiled, subtracted 9, tried to factor, and you couldn't, and then used the quadratic formula, you just went 5 times as long in this question than the student that recognizes to do what? Student number 11. Okay, so student number 11. That is, wait, let me make sure I'm on the right thing. Is it Jaylee? No. Huh? No, you cannot. So Jaylee, whenever you see this, what did I say? What's the opposite of squaring? That's the answer. Square root. And this is actually what happens. The square root of who cares squared is the who cares all by itself. I don't know how else to say it. The square root of Mr. Samulus squared is Mr. Samulus all by himself. All right? Just it frees. They counter each other. So now that's freedom. Anyone ever see Braveheart? Nice. This kid's going places. All right. And then what do I put on the right side, though, based off of the warning? Based off of what we put up here? I'll find it. Right here. Plus or minus 3. Okay, that is for sure. Plus or minus 3. So what does that mean? Actually, I should have split this up into 2 different possibilities. And then you solve each one separately. Okay, so then this becomes 2x equals, add 1, add 1. I really don't need to see these anymore. X equals 2, add 1. I did hit tape, right? We are taping. Oh, no. Did I not? Okay, I did. My old mind just sometimes did I tape yet? Ah, darn it. 2 times 2, I'll bore you. 2 times 2 is 4. 4 minus 1 is 3. 3 squared is 9. True. 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3, but you square it, you get 9. So that second answer does work. You lose that second arrow by not doing the plus minus thing. All right? I'll take care of this one because I don't think we need to do this over and over again because we got to get to the quadratic formula. The bell already rang. I did collect the assignments, right? All right. Okay, so this next one, I'll leave a student alone on this one. The point of this one is you don't square root both sides yet. You isolate. Unfortunately, what that does with this one is creates a fraction. What do you think I always say to do with fractions? 3, 2, 1, go. Reduce. In this one, no, I'm not because I know what I have to do next. I'm going to leave this as 18 over 4. And then I'm going to square root both sides. This becomes x plus 1 free. The reason I did that now, don't blow your minds on square rooting a fraction. Let me just ask you a simple question. What's the square root of 4? 2. Sorry, I didn't do the 3, 2, 1 thing. That's why some people waited. So that actually took care of rationalizing a denominator. If I were to reduce that to 9 over 2, then I'd have the square root of 9 over the square root of 2, and then I'd have to rationalize, and then I'd end up right where I'm at anyway. So sometimes I do those little tricks. And then right here, 18 is 9 times 2. What's the square root of 9, everybody? 3, 2, 1, go. So 3 root 2 up on the top. No, the 2's don't cancel. By the way, what did I do wrong? What should I put in front of this? 3, 2, 1, go. And then the final answer could be this. You could just say subtract 1 and then shove that over. Or get a common denominator, which is negative 2 over 2. So negative 2 over 2 turns into this. All over 2. So imagine, and again, this should not blow a brain gasket, as far as getting common denominators and then putting it over the common denominator. But we have to be used to both, possible answers. Must. So again, this is not, look at how fast this is. Just had to divide by 4. I had to square root both sides. Don't have to deal with the quadratic formula. Don't even have to think about factoring. Um, so on and so on and so forth. And then this last one. Yeah, we'll go to student number 20. Where are we at on that? 13, 14, 15, 16, 17, 18, 19. Do you remember that time in the first? Okay. I'm going to bring that up probably in May as well. All right. What do you think you do on this one? No, we want to get them together. They're all over the place. So how would I balance this out? What do you think I'd do first? Like whatever you do to one side, do to the other. What do you think? Yeah, I would start with that. So do something, not nothing. Oh, I say that forever in cat classes. Don't do nothing. Do something. All right. So okay. All right. Getting cleaned up. Now, do you notice there's not going to be an X term? There is no X term. So what do you think I should move? The 6 or the -8? The -8. Because there is no X term, I will not have to factor. Okay, I will not. I mean, this is a square root solver. I got x squared by itself, so this cancels. This cancels. Oh boy, we're real jerky on these numbers. What do you think you do next? And I'm going to do the same little trick thing. I'm not going to reduce because Mary. The next thing is when I square root both sides. What is the final answer? Well, here I'll help you. First of all, what should I put in front of it? And then what's the square root of 4? And then does the square root of 14 anything come out? Nope. It's just 2 times 7. So nothing comes out. There's your final answer. The 2 cannot simplify with the 14. Okay, just real quick. The next page is the quadratic formula. But let's do this. Calendar. This is for your home fun as well. In case you can't get this memorized, here you go. Oh, yeah. Oh, wait a minute. Oh, no. I, I can only hear it. Oh, that just ruined the whole thing. It sounds really good. I know. Where's the microphone? On? Oh, it's like right here. So if I put this here. Equal to negative b plus or minus the square root. This is for the people at home. All over 2a. Okay, then there's a few more verses. Maybe at the end of the notes we'll play it again. All right. So anyway, that was a fail. Not everything's going to work in here. Okay. All right. So there's your quadratic formula. Yes, you have to have it memorized. Whoever asked that. Arr. All right. Who's next? Boom. Student number 2. Nice. All right. So here's the quadratic formula. And this is when it should only be used when something is unfactorable. I will use it on one that is factorable, though, first, and maybe just one more because of time. Actually, we're not too bad. Is it 55? 50? Still not too bad. I still only do two questions. I don't need to do this over and over and over again. But and there's I used to bore CAT students by deriving this where it comes from. Just trust that it comes from a legitimate math process called completing the square, which Math 2 honors. We did do that for a couple different stuff, like conic sections. And then this is what results. So yes, x equals, the answer is 4x equals that. And then this is, these are just the coefficients in front of each variable. There's where a is. That's where that belongs. There's where b is, the middle term. So the opposite of the middle term plus or minus the square root of the middle term squared. And then the last term just has one spot for it. And again, this comes from somewhere. So it's a formula. You input the numbers in the right spot, calculate, and then you're done, right? Sometimes that is a problem, the whole calculation process. Okay, so I just showed you that, student number 2. I'm going to go ahead and write it again. This is what you'll hear on that song. The opposite of b plus minus the square root of b squared minus 4ac. Wait, I screwed it up. Let's start over. The opposite of b plus minus the square root of b minus 4. I can't. I'm off. I'm out of practice. We gotta listen to it at the end together to make sure I'm in the right spot for 7th hour. So there it is. Now, student number 2, start replacing numbers. So what does b become? -8 plus or minus. Now I would like you to write this. What is b squared and actually evaluate it? No calculator. Get used to those times tables. So what goes in b squared, student number 2? And then minus 4 what? Yes? And then all over. And then this is why previously we had a simplification of a radical that looked like the quadratic formula to make sure you know how to do the next parts. And I'll take care of that because of time. Here's one thing that you should recognize. When I see a minus and a negative in this product, we should be able to see that this is going to be a positive. This is one of the biggest mistakes in the quadratic formula, getting a positive or negative correctly in there. And I'll talk about some other big mistakes that people make. So this is 4 times 2 is 8. This is 72. All right. And then I don't want to put you on the spot today, but it is numeracy. So let's put everyone on the spot. What is 72? What times what where we have a perfect square? 3, 2, 1, go. 8. Ooh. You just blew my mind. I was going 9 times 8. How many people were going 9 times 8? Here, the other person, they said 36 times 2. That's magnificent. So this is -8 plus or minus. What's the square root of 36, everybody? 3, 2, 1, go. Root 2 over 2. And then no 6 over 5 equals 2 errors. Anyone? Okay. You do not do that. That is illegal mathematically. I don't know if illegal is right. Well, you should be arrested if you make math mistakes. Anyway. So -4 plus or minus 6 over 2 is 3 root 2. 3 root 2. Now, that proves that answer. There is no way this would have been a factorable polynomial. I didn't even look at it and try to ask that question. But nothing multiplies to -2 and then adds to 8. So it'd be unfactorable. So these are the solutions. Quick question. This canceled. So I guess I'm fast pacing this, but this is like writing this in 2 separate fractions. But the root 2 cannot mingle with an outside 2. Those cannot cancel with each other. Is that what you're saying? No way. Yeah. No, can't do that. You cannot cancel a root 2 with a 2 outside of it because they're not the same. 2 is 2. Root 2 is 1.414. They're not the same number. So they cannot cancel. They can't mingle in that sense. All right, and I think this one, I'm going to skip to this one. I think this one's actually factorable, which ends up giving you nice whole numbers. So if you got, not whole numbers, you might have a fraction in there. But I'm going to go to the last one. Let's see if the student's paying attention. Last one. Who's student number 9? Nice. Brianna, aren't you? Okay, here we go. Tell me the quadratic. By the way, what I should have said on this one, you're not doing this one, Brianna, but you cannot use the quadratic formula unless you get this equal to 0, and then you go from there. But we're not doing that one because of time. I think it's overdone. So what's x equal? Okay, what do we put first? Plus or minus, and then square root of. Now, what I'm a terrible person at, if going back to this one, you said you weren't going to do this one. It kills me when people put -3 squared and they put -9 as that product. What's a negative times a negative? You know what you are, by the way? You're a button pushing robot. -3 squared. What do I get? Oh, I better put -9 in the box. Ah! A negative times a negative is a what, everyone? Say it. Oh, it's going to happen, though. I have to grade the papers. Continue. Minus 4. Come on. We got to focus. 4, then what's next? And then what? And then what's on the bottom? All over. Okay. And then x equals -2 plus or minus. Okay, please do this. 4 times 5 is 20. I'll do that. 4 minus 20 is -16. You have one more question to answer. What is the square root of -16? Oh, 4. I didn't hear the last part. 4 what? For I, because it's a square root of a negative. Then you'll find out when we talk about graphing, like what does it mean to get an I number? It means that it doesn't cross the x-axis there. No 6 over 5 equals 2 errors. -2 over 2 is -1. Plus or minus 4 over 2 is 2. I know I'm going over that fast, but I have ideas that we know that we could split that up into 2 separate fractions and reduce them. But this cannot happen. Stop it. Okay, I'll finish and then I'll play the quadratic formula video for them.